Hi, this is Bobby Halton, and welcome to today's webcast brought to you by Fire Engineering, Fire Apparatus, Fire Rescue Magazines, and Firefighter Nation website, all parts of the Penwell Fire Group. Today's event, Clearing the Air, What Do You Get for 30 Minutes, is going to be presented by my dear friend Gavin Horn, Director of Research for the Illinois Fire Institute, and that probably should be Dr. Gavin Horn. We're also being sponsored by our great friends at Avon Protection. Avon Protection Systems is a global leader in respiratory protection system technology, working very closely with fire service professionals to understand and exceed our changing personal protection equipment needs. What that means in firefighter speak is that Avon's working with real firefighters. Avon takes the time to put together a tremendous board of fire professionals who know the issues we have in terms of mobility and access and how our equipment really needs to work in context in our environment. And they do everything they can in their research and development section to try to meet and exceed the needs that we have given today's technology and expand that technology into the future. Avon offers a wide selection of high-performance, best-in-class, self-contained breathing apparatus, as well as thermal imaging cameras, escape respirators, asset managing, and also financing options. With 2 million first responders relying on Avon products every day, they now invite you to come and experience the difference that Avon can offer you from what you're currently using. They know that you'll advance with confidence once you experience what Avon has to offer you in comfort, air management, and communications. At the end of this presentation, you're really going to understand what you get for 30 minutes and how important your air protection is. Then please go to avon-protection.com. That's avon-protection.com and look at the amazing line of products that they have to offer. You're just going to be astounded. And they're also great people. They're at FDIC every year. They're huge supporters of fire engineering, fire rescue, and fire apparatus. And they're just great people. So please go to avonprotection.com. Now, before we begin, let's cover a couple of housekeeping items. At the bottom of your audience console, there are multiple application widgets you can use. If you have any questions during the webcast, you can click on that Q&A widget and submit your question. Now, we're going to kind of mix it up today. Gavin and I are going to stay on the whole time, so I'll be looking at your questions. So I may throw out your question live, or we may wait and get it at the end of the broadcast. But we're going to be doing some back and forth here, so we may throw your question up live. In addition, resources are provided for you, such as the PDF of the slide deck, which you can download out of the resource list. And that's that widget that looks like a little green folder down there at the bottom of the screen. You can expand the slide area by clicking on the maximize icon and dragging that. And you can reposition just about any of the components on your screen, so feel free right now to move stuff around so it feels best for you and you get the maximum optimal viewing experience. If you have any technical difficulty during this webcast, click on that help widget and our ACE technician, Tammy, will try to get back to you as quick as she can and solve your issue. If you still need assistance, just type your issue into the Q&A widget and we'll send it off to Tammy and try to get her to correct your problem. For your convenience, this presentation will be on demand within 24 hours of this event, and a reminder will be sent to you. So if you're going to be using it for your volunteer job or the other shifts, you'll be getting that archive, and it'll be up on fireengineering.com. Now let me tell you a little bit about my good friend, Dr. Gavin Horn. He has served the Illinois Fire Institute as Director of Research since August of 2004, immediately receiving his PhD in mechanical engineering from the University of Illinois at Urbana-Champaign. He's a volunteer firefighter, so he does the job right along with us. He's an engineer with the Savoy Fire Department in Illinois, where he was named the 2011 Firefighter of the Year. He's taught multiple hands-on lecture classes at the Illinois Fire Training Institute, ranging from the Firefighter Basic Academy to Rehab Basics to Fire Dynamics and Tactics. He's taught at FDIC and all the national fire conferences across the country, and to departments and training academies around the world. He teaches traditional engineering at the University of Illinois, so he really is a rocket surgeon, where he was awarded the M&IE Alumni Board Teaching Fellowship and was named the UIUC list of teachers ranked as excellent by their students 5 times. He's conducted research in the area of first responder technology and development, firefighter health and safety, material testing and design, infrared imaging, and non-destructive evaluation. He's a senior research scientist position in Illinois. He's a member of the NFPA Technical Committee and Special Operations Clothing Committee. He's on the UL Advisory at the Firefighter Safety Research Institute. He'll be teaching for us again at FDIC this year. And I think more important than all of the things that Gavin has listed here, and what a resume. He's an outstanding gentleman. He's a truly elegant representative of what it means to be a firefighter in the year 2015. He's a tremendous father and husband, and he's a great friend and an absolutely engaging gentleman. Ladies and gentlemen, without any further ado, we'd like to introduce to you today the lead presenter, Dr. Gavin Horn. Gavin, it's all yours, buddy, and I'll be hanging in here with you.
Great. Well, thanks, Chief. I really appreciate the introduction, and I hope I can live up to that great background that you provide. So I really appreciated it. So this is a presentation that was put together for FDIC this year, and it's an hour and 45 minutes. We've kind of boiled down to 45 minutes worth of work. And the nice thing about FDIC is we had a whole lot of back and forth. In fact, the first 45 minutes to an hour of this program was really just talking back and forth about the different fire departments and firefighters' experiences with the SCBA they have, and changes that are coming both in what's on the market and how they're using their SCBA. So there's a couple different titles that are thrown around for this. One is clearing the air. What do you get for more than 30 minutes? Or what do you get for 30 minutes of air? But a corollary to that is what happens if you have to fight fire with more than 30 minutes of air. But in all cases, we put that 30 minutes in quotes because we always refer to these SCBA based on the amount of air that's determined by a very special formula, basically assuming that someone's breathing at 40 liters per minute. So with a 1,200 liter SCBA, that's 30 minutes. We want to talk about what does that mean? What can each individual really achieve with 30 minutes of air? What are some of the issues that come about with these current SCBA and as sizes get larger from traditionally what we've had with this 1,200 liter or 30 minutes worth of air? So I'd really like to be able to maintain that kind of conversational style that we had at FDIC, and on this webinar format might be a little bit more challenging. So this is why hopefully Chief Halt and I will have a conversation throughout, and these slides will just be acting as a background. You'll see different topics come up and some data that I'll pop up here that will hopefully help support some of our conversations. But I'd like to encourage everyone out there to ask questions as they come about, and if we can, we'll just put them right in here and we can have a conversation based on your insight. But since you've signed up for this, I think you should really get an idea of what to expect over the next 45 minutes. So this is basically a topic. I'm going to start off talking about some of the statistics in the fire service. I think it's important, I do this in most of my presentations, just to make sure everyone's on the same page and understand where the fire service sits currently and historically in terms of some of the injuries and fatalities we're facing on the fireground. We'll talk about air usage on the fireground, a little bit about air consumption rates, and this obviously depends on a lot of different things, and we'll talk about those. Importantly, work versus rest cycles. Many of us, our operational reality in the fire service is that you're likely to have to work through 2 or maybe even 3 cylinders of air. And I know I expected maybe a little bit more out of myself on those second cylinders than I really could do until we ran a study and started to quantify some of those things. We'll talk about physiological responses, and really from physiology, we're looking at what's the heart rate, what's the core temperature, how does that affect our ability to do the job? And then changes a term that we're using called safety of movement. How do we move on the fireground? How does the fatigue from the work that we do and the different size of the breathing apparatus that we have on our back affect our ability to move and walk and cross over obstacles and go up and down stairs and things like that, so that we can avoid some of the injuries that are common on the fireground? And then at the end, we'll wrap up with some conclusions, talk about some tactical considerations, and points you to a location where you can download a full report from a DHS-funded study that we've run. There, it's free to anyone from the website at IFSI. And really, this is just kind of going to give you a teaser to some of the data that we collected. And you can go find that report And hopefully it will provide you some new insight and some new information, because we need to look at the issue from a holistic standpoint. When we're deciding what SCBA to purchase or deciding on what are the necessities for work rest cycles and how that might come into mutual aid or manpower decisions, we really need to look at everything from a holistic perspective. And that's one of the reasons we start off looking at some of the statistical data. So if you look at this plot, and again, there'll be a fair bit of data I'm going to show you here, and I don't apologize for that. I think the fire service understands a lot of this information, even though many times we'll kind of maybe downplay what we understand or what we can understand. But I think if we look at this data, it's pretty easy to understand and see how it impacts our lives. So this is some fatality data, the number of line of duty fatalities in the fire service plotted from 1990 all the way up to 2013, the most recent data that we have from NFPA. And you can see typically we're looking at on the order of about 80 to 100 fatalities each year. Fortunately, we've had a nice significant decline over the past few years, though 2013 we did have a couple of large loss incidents that caused that number to spike. But importantly, what we're finding year in and year out is the leading cause of fatalities in the fire service is sudden cardiac events. And that's due to the stress and the strain of the firefighting activity itself. Now, we could talk for an hour about some of the risks from firefighting in terms of how that causes or potentially triggers sudden cardiac events in the fire service. And that's a whole other line of research that we do here at IFSI. But today I want to put this in the context of the gear that we wear, and particularly how the selection of the gear that we wear from SCBA to PPE can affect, if we make a decision for one type of injury or one source of the fatalities, there's maybe some unintended consequences for how that might affect us in the other jobs. So this is the exact same data that I showed on the last slide, number of fatalities, 1990 all the way up to 2013. But it's kind of broken down a little bit different ways. So the red bars in the back of the sudden cardiac events, the green are asphyxiation-related fatalities, and blue are the burns. And you can see in a typical year, we'll have 10 times more sudden cardiac events than we do from the asphyxiations and the burns. But if you think about the evolution of the gear and the changes that are being made, in many cases, they're driven by some concerns for these other types of fatalities in terms of becoming more encapsulating. Now, there's certainly a lot of other good reasons to improve the encapsulation of our gear, but initially it was driven by some burn concerns. If we look at some of the trends in the fire service moving to larger and larger SCBA, at FDIC, what many people said, they're concerned about running out of air on a job. But in a typical year, the number of fatalities due to asphyxiation events are an order of magnitude 10 times less than some of those we have from the sudden cardiac event or the overexertion and strain-related fatalities on the fireground. You see every once in a while there's these large spikes in this data, and I want to point that out. Say, for instance, 2013, the burns, in 2007, the asphyxiation fatalities. Typically, those are years where we have a large loss in a wildland fire, and that was the case where you see each of those spikes. So this includes the structural and the wildland. If we just look at the structural firefighting, some of those spikes will not be there. So if we look now at some of the purchasing trends and the concerns in the fire service of running out of air, that might drive our purchasing decision towards the larger SCBA that have 60 minutes of air as opposed to the 30 minutes of air. And there's some very good reasons for that. For operational realities in some departments, we certainly need to think about that. We also need to consider how working longer, working for more than 30 minutes, carrying more weight on our back, might affect some of our risks for the overexertion types of injuries. And the same thing pops up when we look at the injuries on the fireground. Okay, and this is the exact same data from NFPA Journal. What we're looking at here now is the number of fireground injuries, so this doesn't deal with any of the injuries and other around the station or medical calls or whatever, just the fireground injuries from 1990 to 2013 again. And what we see if we look at the trend over time is a nice downward trend. We're seeing a significant reduction from almost 60,000 down to about 35,000 fireground injuries, which is a great thing. We're a little bit less excited when you kind of put over the top of this the number of fires that we're going to. And you can see that if you plot the number of fires right over the top of the number of injuries, the rate per fire is about the same. So we're reducing the number of injuries, but that's due to a reduction in the number of fires. And the injuries per fire. Go ahead, Chief.
I have a question for you here, which I think when we talk about analyzing data, if we looked at when we spoke about our line of duty deaths, we always point out that wildland fires, because of the numbers involved, tend to be skewed, or tend to skew the overall numbers. Like if we have a bad, like Storm King Mountain or Yarnell,
yeah.
we certainly see those spikes those years. When we're talking about the injuries, because we're looking at much longer campaign fires in wildland firefighting, coupled with what I think to be much better reporting instruments than we've ever had before. Could that account for some of these injury numbers increasing? In other words, when I first came on, back in the 70s and 80s, if someone cut their finger or twisted their ankle, generally it was like an in-house issue, and you may have taken a day off or whatever, and you may not even have reported it. You may have just bandaged it up yourself and gone back to work. But today, because we know more about infection and illness and the importance of documentation, we tend to capture trips and falls and slips and falls and overexertion much more aggressively than we did 20, 30 years ago, even 10 years ago. Do you think that could be? And I'm not saying it's just reporting, but is there any way to filter that or look at that?
Yeah, it's a great point, Chief. And unfortunately, it's incredibly difficult to go back and look at those things retrospectively. And it's a great point. We're much more aware of the need for data, particularly in terms of some medical coverage, why we might need to report some of these. And the process changes a little bit over time. So there certainly is a possibility for that, and it's a great thing that we are starting to get a little bit better data in terms of some of the injury risks. But this data is imperfect, and many of these provide some measure of estimations of the total number of injuries on the fireground. And we feel that in many cases they're still vastly underreported. For instance, looking at the slip, trip, and fall injuries, there still are a fair bit. I think most of us at some point or another have tripped and fallen on the fireground and maybe bumped an elbow or scratched themselves or something like that. But usually you'll get up as fast as you can and look around and make sure no one caught you doing that. Those are ones that we don't report. We're trying to not be that guy who just fell on their butt on the fireground. So when we look at these slip, trip, and fall injuries here, and then you can also look at it from the dollar cost in terms of the amount of time away from the job, backfill and overtime, what it costs the fire department from insurance in those categories. These are some of the largest losses, largest time away. So these are those injuries that result in the sprains and the strains and the broken bones and those sorts of things that cost a whole lot of money. But your point about reporting, that it's difficult to tease out, and it's a point very well taken, and something that we need to continue to improve, I think, in the fireground. We can make a lot better decisions about things such as purchasing decisions, such as manpower decisions, if we have better data in terms of injuries, in terms of every little bit of fireground activity. So it's a point well taken, but I can't give you a good answer on that one just yet.
Well, thank you.
But the point from this graph here as well is even though the number of fires are going down and we're looking at this similar number of injuries per fire, if we look at the number of slip, trip, and falls, overexertion, and strain, whether it's due to reporting or due to the fact that there is some increase, we see a slight decrease overall, but if we look at the numbers per fire, those are actually increasing. There's a lot of possible reasons for it, one of being the reporting differences, but another possibility that we need to take a look at is the evolution in the gear that we're wearing, becoming more encapsulating, heavier equipment, more stuff that's being hung on ourselves. Is that affecting our ability to do the job and possibly some of these risks?
Hey, Doc, I know you want to go there, but we've got a great question from Bob Hoshield.
Okay.
He's asked, do you think that the number of injuries or deaths are being affected at all due to the average age of firefighters increasing due to the lack of new, younger volunteers? In other words, an aging workforce. Do you think that could be contributing to it? Or has that been filtered through there also?
Yeah, that has not been, again, another one of those things that goes into the mix here, and it's a great point. And there's a lot of different things that can come into play here. This data from NFPA journal is not specifically parsed out from that perspective in terms of the total fireground injuries, but they do look at the types of injuries based on the age range. And what we see is typically a lot of these musculoskeletal injuries are from the relatively middle-aged group, so the firefighters within their 30s or something like that. But it is true that we are seeing firefighters a little bit later into their careers who are still doing some of this work. I think in addition to the age of the firefighters, we can't go away from understanding the effect of fitness and the effect of preparation for the job in terms of body size. And a little bit later in the presentation, we'll talk about a little bit of that, particularly in terms of ability to do the job for 2 cylinders of air. All of these things come into play, and I think we could talk about this honestly for the next couple hours. But it's one of those things that's important to understand and to consider. I can't give you a perfect answer on that yet, but I think it certainly does fit in the mix of this question. So, excellent question. So, moving on. With the background of the injuries and fatalities in the fire service, we wanted to take a look at what could possibly affect us. Right? If we do focus on the SCBA portion of this, the reason we chose to really kind of drill down on this area, on every little bit of the personal protective equipment that we wear, the SCBA is the single piece of equipment that weighs the most. You know, the bunker gear, the boots, everything else, nothing weighs more than the SCBA itself. It also causes the biggest shift in the center of gravity. Most of the weight that we wear in terms of PPE is relatively well balanced front to back and side to side on the body, except for the SCBA, which hangs all off of the back and has a significant increase in the change in center of gravity. So that changes the way we move through the world. It changes the way our shoulders work than if we didn't have that extra weight hanging off of there. And it causes some of the largest restrictions to the range of motion. There's some great work that's been done at various different places that show every different piece as you add it to the body. Nothing affects our ability to move and our range of motion in our joints as much as the self-contained breathing apparatus. And at the same time, we've seen a significant change in the trends of SCBA purchase. Now, anecdotally talking to a lot of the manufacturers, many of the departments are transitioning away from the extended duration SCBA. And again, there's a lot of great reasons for that, but one of the most common that I hear, again, is the concern about running out of air, not having enough air to do the job, worrying about the injuries, being trapped and running out of air. And so the last little bit of data before we start getting into some of the study is looking at fireground injuries by cause, again, just for 2013. And we break that pie down, that 100% down. If you look at the changes in the center of gravity, changes in range of motion, changes in the amount of work that we're doing due to load carriage, those are going to have a significant impact on the overexertion strain injuries and the slip, trip, and fall injuries, those 2 leading causes which account for about 50% of the fireground injuries. But if we look at the number of injuries due to exposure to fire products, and that's not just to the scenario where someone runs out of air, but that's total number of injuries to fireground products is about 10%, so it's a fifth of those from the other sources. Again, they're very important to understand and figure out how to counteract and reduce the risks for those injuries. But when making these decisions, what we want to be able to do is have enough information to show what is a trade-off. If you are reducing the risk or the likelihood of exposure to fireground products by having a larger SCBA, what can we do, what can we think about in terms of how it might affect our risk for these other 2 types of injuries so that fire departments can make some of these decisions? Our whole goal is to get data out there in the fire service, not to say that this is more important than the others, but to provide you all with some thoughts when you're going through training to improve the awareness for your firefighters, when you're making these purchasing decisions to say, hey, this is something that we can balance based on our operational reality. I think that's the goal of all the research, is not to tell people this is what you should do or what you need to do, but these are some pieces of information you can take when you're making that decision, and you can then balance that decision from a more, I'll use the term, holistic standpoint, taking as much into account as you possibly can. So to support that, what I want to get into here for the next 30 minutes or so is a study that was funded through the Department of Homeland Security through the Fire Prevention Safety Grants that we ran it at the Illinois Fire Service Institute. IFSI is a state training academy, but we also have a research arm that's embedded into the institute. We happen to be a part of the University of Illinois, so we have access to some of the great research minds on this campus and in the country here to help us to look at that thing. So we were specifically looking at the effects of the SCBA design, and from that case, we're looking at the volume of air. So commercial 30-minute, 45-minute, and 60-minute SCBA, as well as the geometry of SCBA air containment. So we also were looking at a prototype low-profile design that many people have seen. So if you take a look at some of the pictures that we have here, it shows you the different sizes of the SCBA that we looked at in this study. We're also interested in energy expenditure during the firefighting activities. So what happens when you're wearing this gear? How much energy did you expend before and after the firefighting? What are the risks? But also, how does the size and the geometry of the gear affect the energy that you're expending doing the same job on the fireground? And we were interested in this, looking at, again, the safety of movement on the fireground. So doing a functional balance task. Balancing is a very difficult thing on the fireground, and it's also very difficult to measure. So turns out that firefighters, after you get done doing the work, are hot and tired and wearing the gear. It becomes very difficult to stand still and do some traditional balance measurements. So we had to design some new tasks in order to do this. We're interested in looking at how firefighters walked on the fireground, not just on level ground, but also going up and down stairs, crossing over obstacles, because we know the fireground is a very cluttered place. So we need to be able to take a look at each of these and how they're affected by the size of the SCBA, as well as by the fatigue that we're accumulating while we're doing the work on the fireground. So this project, again, was funded by Fire Prevention Safety through the research and development grants, and projects like this and many other research that's going on around the country right now, it just wouldn't be possible if it wasn't for some of the funding from DHS. So we're very much thankful for them, as well as some of the other partners that we had working through this project, and including the participating fire departments from across the state of Illinois. Some of these firefighters drove about 3 hours each way to go through up to 12 different test scenarios that we put them through. We're not going to have time to go through all of those, but I'm just going to kind of touch on a few of those things, give you a little bit of feel for the data, and then give you the location where you can get the full report and go from there. Again, as I mentioned, this is a team sport, so we have individuals working with us on this project from across the University of Illinois, expertise from biomechanics and motor control, exercise physiology, cardiovascular effects of firefighting activities, human factors, and of course want to make sure to acknowledge Richard Kessler, who really was the driving force behind running this project for us. So I get the joy of being able to talk with everyone here, but it's due to these people helping us and their expertise that we can really make some impact here in the fire service. So a little bit more background. This is the size of the SCBA that we looked at. Again, these are sizes that are very familiar to most of you, and there's some terminology I want to go through that will help you understand the rest of these slides as we go through them. So if you see S30, S45, or S60, those are the traditional single-cylinder SCBA. You've got 30-minute SCBA. Again, that's 30 minutes assuming we're breathing at 40 liters per minute. So that's a 1,200 liter of air cylinder, whereas the S60 is a 2,400 liter of air. As I mentioned, the picture on the bottom right-hand part of the slide here, you can see the prototype low-profile design and all the dimensions you can see right here. And again, you'll be able to get all of these slides downloaded. You can go through all that data. It's not important that you look specifically at the numbers here, except to see the difference in the size, the mass of the SCBA. So the SCBA with a 30-minute bottle is about 22 pounds. 60-minute bottle is almost 29 pounds. It's important also to remember that the air that we have on our back, if you take 1,200 liters of air and compress it down into what we're carrying on our back, that's about 3 pounds. So if you're carrying 60 minutes of air on your back, that's 6 pounds of air in addition to the physical weight of the self-contained breathing apparatus itself. Of course, when you get more air, you have a trade-off of the difference in weight, but also the difference in how far it hangs off of your back, the size, everything else that comes into play with that. We did a study that used simulated firefighting activities, and I'm going to talk a little bit about this just to introduce some of the data that we had right here. And firefighting, as we know, is very intermittent, right? So we do a lot of different tasks on the fireground, and a lot of research that's being done in the fire service. What it does, it puts firefighters in the gear, puts them on a treadmill, has them walk for about 20, 30 minutes, and says, okay, what happens? How has the different designs of the gear affected you? And that's great because it's a very controlled work cycle, but it doesn't necessarily get to what we really do on the fireground. what we typically do is have firefighters do different tasks on a 2-minute work rest cycle. So they're climbing stairs for 2 minutes to take a break, working on advancing hose, such as humping a whole bunch of hose into a large box store for 2 minutes and you take a break, 2 minutes crawling, searching in a secondary search pace, and then taking a break, and then 2 minutes doing an overhaul task. So this is the typical activities that we had the firefighters do. And this was validated against live fire activities. For this study, because we can get a lot more data if we do this in a laboratory environmental chamber, there's a lot of great stuff that we can do that we can't get out in the burn buildings. But I'll show you a little bit of data where we went back and validated that this protocol matches very nicely with what we have on the Fireground and does a much better job than some of the treadmill protocols. So I'd say as a word of warning, we got to make sure when we read the data, for those of you out there who are really interested in this data, make sure you look at what that protocol is so that we're asking the right questions to getting the right answer. Okay, last bit that shows the terminology that we're using on the remaining slides right here. We had 30 different firefighters complete 7 different trial conditions. Okay, and the trial conditions are listed out as you'll see S30, S45, S60. Again, that's the size of the air bottle, and the 1B, that's 1 bout worth of firefighting activity. So that's where they go through the stairs, the hose, the search, and the overhaul task, and they do that 1 time, and then they go out. So that's about 16 minutes worth of, 14, 16 minutes worth of time in the chamber at high temperatures, 8 minutes worth of work. And for the typical firefighter wearing a 30-minute SCBA, they would be going on the bell by the time they get done with this. And there's a huge variability, of course, and a huge range, which we'll talk about. But typically, most firefighters will be working to the point where they would be on the bell at that point. And this isn't the case, but this was with the older SCBA, so using the quarter service alarm, not the new 1/3 service alarm from the end of service time indicator. We also did these tests, the same tests, with a 45-minute prototype SCBA. One of the first things that we did in this project, hadn't been done before, was looking at a controlled amount of work. If you said, okay, what happens now if we do 2 rounds, 2 bouts worth of firefighting activity? So we had them work through that typical work rest cycle, head out from the chamber for 5 minutes to get a quick drink of water, change out the bottle so it's a fresh bottle, and then go back in. And this is what happens now. We were able to measure what's the difference in the physiology, what's the difference in the ability to do the job on the Fireground on that second cylinder of air. That hadn't been done before. Most of the work that we do really stops after that first round of SCBA. And so we could look at what happens if you had a 30-minute bottle and you had to go out and come back in. We also did a scenario where we didn't go out. If you got a 60-minute bottle, you don't have to take the break. So if you just stay in for that entire period where you're going through twice as much work without that rest. So that's what we're calling the back-to-back, S60 back-to-back scenario. Okay? So these are multiple different types of tests and pieces of information that we can get out of this. There's a lot of different comparisons we can make, just looking at the differences in the size of the SCBA, looking at the differences in the design of the SCBA, looking at the side if we have that same size of the breathing apparatus, 1 bout versus 2 bouts with a break versus the back-to-back where it's 2 bouts without a break. And then how that changes if you've got 1 versus 2 rounds with a smallest commercially available SCBA versus the largest commercially available SCBA. A lot of very complex statistics that go into making those types of analysis. Won't nearly have time to talk about that right now, but that gives you an idea of some of the information that you can find in the report that's coming out. All right, so information that we learn. Air consumption rate, right? As we all know that the sizing of the SCBA is based on the 40 liters per minute standard air consumption rate. And we also know that NFPA 1981, the SCBA are tested at 40 liters per minute, and then that high level. The high level is about 103 liters per minute. But as we were doing this test, we wanted to give everyone a good idea of what 40 liters per minute would translate to. And many people have never really gone out and tested. What does it take? When are they breathing at that rate? And the best analysis that many of you might understand, or the best analogy, I think, is we had all of our firefighters complete a graded exercise stress test. I know many of you do that either for a yearly physical evaluation or when you get on the job, that initial test. But basically, we found the average firefighter reached 40 liters per minute when they were walking on the treadmill at 4.5 miles an hour. So for most of us, that's a nice brisk walk. Some of the smaller people might have to do a little jog there. Some of the taller individuals, they could walk at this pace quite comfortably. But 4.5 miles per hour. That's wearing shorts and a t-shirt in a relatively cool, air-conditioned laboratory environment. That's what you can expect to be breathing at 40 liters per minute for the average firefighter. And I think that most of us would agree that that really is not what we're facing on the fireground. What does it mean, though, for us on the fireground? What does this really look like on the fireground? Well, here's again where we start to get into some really hardcore data. And again, I want to use this as a background and just to introduce some of the more recent information that we have available to us now. This is a pretty complex chart, but I want you to think about this just looking at, say, the blue line. The blue line is the heart rate, and this is some data that we collected from firefighters working through a training exercise. It was a 3-hour training exercise, basically doing coordinated fire ground attack here at Illinois Fire Service Institute in our concrete steel burn structures with pallet and straw fires. But you can see each time, if you can see my mouse on my cursor on the screen here, we go up at about 2 minutes. There's about a firefighting activity, and then they go into rest. You can see the red line here, which is the core temperature increases. It peaks a little bit after the firefighting activity is done, and then it goes back down. And you can see that these work-rest cycles typically on the fireground last about 20 to 30 minutes, depending on how much air we have in the SCBA. What we just started to understand now is even within those work-rest cycles, while we're working through one cylinder of air, if we zoom in on those areas, you're not working constantly, nonstop. The firefighter is working off and on, doing things and coordinating with the other activities on the fireground. So there's significant maximal heart rates. We're talking about heart rates here in the order of 180 to 200. That's as hard or as many beats per minute as these firefighters are going to be able to maintain. They're working as hard as they possibly can in terms of their heart rate. And you continue to do that, but even throughout each time you're working, it's not continuous. It's not walking on a treadmill. You work and you rest and you work and you rest. Well, the scenario that we built in the environmental chamber, just wanted to show you the same thing, this data here. So this is heart rate from the environmental chamber here on the bottom of the slide. We can replicate that same type of work-rest cycle. If you look at the data on the bottom, the red points are the firefighters working in the environmental chamber, and the green points are the firefighters working in the burn buildings. So we see very similar types of heart rates, same types of work-rest cycle in our chamber versus the burn buildings. Very different than the blue data there, which is walking on a treadmill. Now, I share all that information with you because we did this study in the environmental chamber due to the fact it allows us to get a lot more interesting information about the firefighters' breathing rates and energy consumption rates. And so now if we look at the data that we can get there from an oxygen consumption tool, this chart on the top now, this is the ventilation rate. This is the amount of oxygen that is being consumed, the amount of air that's being consumed per minute during these firefighting activities. And what we see here very quickly is that 40 liter per minute rate, which is a yellow line here, is exceeded. Within the first minute on the fireground, within the first minute of work, the firefighters are working at over 40 liters per minute. And in fact, they never returned back below that 40 liter per minute after that first rest cycle. Even during rest, firefighters are breathing over 60 liters per minute, over twice as long as we might expect for that 30 liter per minute bottle. We also found that some of the maximum rates that we were measuring is over 150 liters per minute. Okay, almost 4 times the rated rate when firefighters are doing this work. And one thing that comes as a surprise to many people, Chief, and I'll ask you maybe your opinions on this. During FDIC, we posed the question: if you had 2 individuals who are doing these activities, one person was, their BMI was in the 35 to 36, obese, low fit, versus the CrossFit, the person who's out there working their hardest. The person who is fit for the job, has practiced, has made themselves as ready to do this job as possible. Which one do you think is the one that was breathing closer to this 150 liters per minute?
Well, I know that's kind of a trick question because I guess the more fit we are, the faster we start to consume oxygen. Isn't that what happens?
Mm-hmm.
I mean, I've always heard I'm a runner, and then I've always heard that because I'm a runner, I'll go through my bottles faster than people who are not, because I've got greater capacity and I'll suck it down.
Yep,
you got it. Did I get it right?
Yeah, and so you've got a great insight from that, and that's exactly what we find. People who are more fit that will be consuming the air more rapidly. And part of it is a lung volume being trained, but also part of it is ability to do the work. The people who are fit and who are trained, we see them usually have higher heart rates, have higher breathing rates. And in fact, in this study, we had some of our fittest firefighters who we actually had to put them on a RIT pack to finish this study because they went for the 30-minute bottle because they consumed that 30-minute SCBA so rapidly. And these are people who were perfectly
younger firefighters will also do that, or I mean, not younger because they're younger, but I mean less experienced. Wasn't that one of the other things that we found and Dr. Brown found?
Yes, there's also things, younger firefighters possibly either they're not as familiar with doing the tasks, they're not as efficient with doing some of the same tasks, they might be a little bit more excited. But in this case, we looked at, they were basically the same age. There was no significant difference in experience between this. And this is not a statistical analysis I'm talking about, but this is anecdotally. We find quite often those people who are fit and ready for the job, they can do more work, and they end up going through their air bottles faster. And this is one of the concerns that was also raised at FDIC in our conversation is some of these people who can really do the job of the 30-minute SCBA, they have to come out. They don't have enough air. They could still do work and continue to do that work safely, but they're limited by their ability to do the work based on the size of their breathing apparatus. So that's an important thing that we need to consider. So there's a lot of differences here in these breathing rates. So 30 minutes of air for some of these individuals, some of our fittest individuals, after about 6 minutes worth of heavy work, they were on the bell, and by 8 minutes they were done. They had no more air left. They had to go on the RIT pack to continue. And again, this was in a very controlled environment. We were able to continue to keep them in there with all the monitoring that we do here. But it's an important consideration to have. It's very important for us to think about. How does that affect the work-rest cycles for our firefighters on the fire ground? Now we also want to look real quickly at some of the data. How does that affect the physiology? Heart rate, core body temperature, and importantly the size of the SCBA. And there's a lot of data here that I'm just going to go through relatively quickly because, to be honest, we saw very small impacts. We saw firefighters working basically as hard as they can, their core temperature changing almost the exact same way. So in here, if we look at, we've broken down now just one round of firefighting activity. The maximum heart rate didn't really matter if you're wearing a 30-minute SCBA, a 60-minute SCBA, or the prototype system. Those differences are very, very small, not significantly different. It was the same from core temperature perspective. The core temperatures in each case raised about 1 degree Fahrenheit, regardless of what sort of breathing apparatus was used. So the good news here is that there was not a significant impact from a 30-minute versus a 45 versus 60-minute SCBA in terms of ability to do the work. Firefighters were able to work as hard as they could. They felt about the same. It did not have a huge impact on their ability to do one bout of firefighting activity. The really interesting thing that came in here is what happens when we start looking at that second bout of firefighting activity. And again, this is something that had never been done before. How does it affect our abilities and our work on the fire ground? Okay, so this is the same data that we just looked at from a single round worth of activity. And now we look at that second round, especially when we do 2 bouts back to back. And what you can see is there's a significant increase in the heart rate, the average heart rate that was achieved and the maximum heart rate that was achieved. And I'll tell you, heart rates at 180 beats per minute is very near maximal for this age range. They got up to almost 190. So the maximum, the heart rates that were achieved here after the second round of activity was 100% of what they were able to achieve on the graded exercise stress test. Firefighters on average worked as hard as they possibly could work. Now they were at about 95% of that in the first round of activity, but you see that heart rate got driven even higher. If we look at the core temperatures now, core temperature increased significantly and much higher. So while it increased on the order of about 1 degree Fahrenheit, it increased to about 2.5 degrees Fahrenheit for the back-to-back route, where there was not a rest period that was allowed in here. So the increase in that core temperature was more rapid in the second cylinder of air. These firefighters were getting up to core temperatures that were approaching 102. In some cases, we had firefighters reaching into the 103 degree range. Okay, getting to the point where some of these firefighters working very hard, we have to be concerned with their core temperature so that it doesn't accelerate much higher than this. And if we look at the amount of time that they were allowed to rest, those temperatures started to get very high. Over 3 degree increase on average from firefighters from the beginning to the end of these activities. So that second bout worth of firefighting activity has a significant increase in the heart rate. The heart can't beat any faster for most of these firefighters. The core temperature was starting to get to a point where we need to be very careful with these firefighters. Make sure that they get the rehab and the rest and the time that they can have off in order to recover before we go back into another bout with the firefighting activities. And we saw that there was a slight difference when firefighters were allowed to have that 30-minute break in between the two air bottles. Once you go past that work-rest cycle for a 30-minute SCBA, many firefighters felt like they had to have that 30-minute break, or that 5-minute break where they could go on, get a little bit of water, take a rest before they could go on and continue the second cylinder of air. They felt it was much more difficult, and they weren't able to do quite as much if they went right back to back.
So that core temp is a really critical. That core temp is a really critical issue, then, right, Doc? I mean,
yeah, the core temperature is really critical when we look at our risk for hypothermia. Right? We want to make sure that our internal temperature does not get too high and increase the risk for heat stress, heat stroke, and up to some of the heat-related injuries that we can have on the fireground. And at the Redmond Symposium, we just did a presentation with Chief Craig Haig from Hanover Park, looking at rehab and the value of rehab and when you need to institute rehab. But this shows us that, the standard says after 2 cylinders or 1 60-minute SCBA, and you can see here the increase in the rate of that core temperature increase of that second cylinder of air, and just really want to drive home the importance of rehab and why we need to take a look at that in particular. The other thing that's difficult on the fireground is measuring the core temperature. There's no real good way for us on the fireground to measure that. In this case, we had firefighters take a core temperature pill that got into their gastrointestinal tract and very accurately measures the core temperature, but that's not something we can do on the fireground. And the tympanic and the oral thermometers are relatively inaccurate in the field environments. So we need to be able to keep an eye on what we might expect from our firefighters. In a lot of cases, you can take a look at them and understand, do they feel hot? Are they reacting appropriately? Because once you start to get to these elevated temperatures, significant decrements in performance, as well as in some individuals' ability to function, their cognitive function on the fireground. But these temperatures, again, not to this point where they were concerning from a medical perspective, but we can understand that if there was not some sort of rehab intervention, how they can continue to be driven up through more cylinders of air. But much higher increases in the second round of firefighting than in the first round. Now, we also looked at how much work was done on the fireground. And so in each one of these sections, we basically measured how many stairs, how many flights of stairs the firefighters could take, how much hose they could hump into a large box door or something like that, the distance they could cover in the search, as well as the amount of times they could pull on that ceiling throughout that 2-minute cycle. And so what I've plotted here, and there's a lot of data on here. I apologize for how much you're seeing all at one point, but what this shows us is all the different conditions. It doesn't matter if you have a 30-minute bottle, 45-minute, 60-minute bottle. They did basically the same amount of work for that first round of activity until they came back for that second round of activity. And I was one of those guys who always thought I was just as good in my second cylinder of air as I am my first cylinder of air. And it's just not the case. We had, out of the 30 people who came in here, about 2 of them who could maintain the same level of work when they went to the second bout as the first. Most people were able to do 25% less. So even though that standard for rehab suggests that you don't need to go to rehab until after the second cylinder of air, what we're seeing here is you can do that work, but most firefighters on average could not do the same amount of work for that second cylinder of air. They couldn't do the work, and in each case, if we look now at that heart rate data, the heart rate was significantly higher for that second bout of air. Right? So this tells us that when we work through more than 30 minutes of air, we have to understand the limitations of our individuals. If it's possible to get a second crew in for that second bottle of air, if the manpower is there, if mutual aid is available, that's critically important to getting that out on the fireground. We can help to relieve that. Now, for many of us, the operational reality is that, no, you're going to have to go through at least 2 cylinders of air before you go to rehab. But I think it's important for our incident commanders to understand that that second cylinder, you cannot expect the same amount of work as you can out of that first cylinder of air. Another bit of data here that I think ties back into one of our earlier questions on fitness and age of the firefighters. mentioned we had 3 different scenarios where firefighters worked through 2 bouts of air. So where they had to go back to back or go 2 rounds of firefighting activity. And we told the firefighters at the beginning of this study that if there's any points you feel too hot, too dizzy, too nauseous, for some reason you don't feel that it is safe for you to continue, we want you to come out from that struct. Come out from the scenario, and we're going to call it quits there. If they are concerned about their safety, where we didn't ask them to push themselves through that, we asked for them to come out. On these 3 scenarios, we had 30 firefighters. 11 of the 33 firefighters were not able to complete one of those 2-round cycles. Right? So not only did the work decrease, not only did the heart rates increase, a third of them said they didn't feel that it was safe to continue. Now, if they're on the fireground, they might have pushed through, the adrenaline might have been pumping, there might have been some differences, but their feeling was that it was not safe for them to continue at this point. And we did a little bit of analysis on those. So we called the 19 groups that did complete the trials compared to the 11 who were not able to complete those. And actually, in this case, we didn't see any difference in the age. The non-completers were a little bit older, but if we look at statistically, there was no difference. Where we found a statistical significance was in the weight, in the BMI, and the VO2 max, which is a measure of the fitness. So if you see what's highlighted in red right there. Looking at BMI, for instance, on the 19 firefighters who could complete, their average BMI was about 26. And for those of you who are familiar with the categories, you'd realize that 25 is that cutoff. Less between 20 and 25 would be considered lean or normal weight. 25 to 30 is the overweight category. Now, if you look at those who did not complete, on average, their BMI was 30. And again, that's right at that range, the difference between the overweight, which is 25 to 30, and the obese, which is 30 to 35, or 30 and above, actually. So there's a significant difference in the body mass index and the obesity of these firefighters. Significant difference in the VO2 max. VO2 max, again, that's a very accurate measurement about the body's ability to consume and use energy in order to, it really tells us how well we can do the job. We can translate that to our ability to work on the fireground. The group of 19 that could make it through, average VO2 was about 46, whereas those who could not complete their average VO2 was about 40. And again, just to give you a little bit of context, the NFPA suggested minimum is 12 METs, or 42 ml per kg per minute. So on average, the group that were not able to complete was below that, and on average, the group that was able to complete are above that. So it shows us that just as important as the size of the SCBA is our ability to prepare ourselves to do the job on the fireground. If we are leaner and more fit, we're more likely to be able to complete that second cylinder of air. So this obesity and fitness, the conversation often revolves around risk for sudden cardiovascular events and things like that, but it also affects our ability to perform on the fireground. Okay, and we're getting near the end of this the webinar here, I think. So I just want to quickly introduce some of the work
Doc,
that we did looking at the safety.
You got plenty of time, Doc.
There's time. Okay. Well, in that case, we'll just touch on a little bit of this data, because I also want to drive home that while the size of the SCBA affects, again, the heart rate and the core temperature, it also can affect our risks for just being able to move safely on the fireground. So we were looking at these effects, and we used this obstacle course that we developed at the Illinois Fire Service Institute, a bunch of different obstacles, and we used some really high-tech instrumentation, some three-dimensional motion capture simulation or motion capture technology, which is really similar to what a lot of people are using for video gaming technology to be able to understand how the human moves so they can recreate that on the video screen. It's used in a lot of different scientific studies looking at how people move, as particularly individuals who are at risk for falls, such as those who are elderly or who have some gait impairments. And we're able to take all of that information and bring it out to the Fire Service Institute to look at firefighters for the first time in this. So this is what the obstacle course looked like that we set up at the Illinois Fire Service Institute. As I mentioned, we used an 8-camera kinematic motion capture system. That's a fancy way of saying a motion capture system where we attached little markers at points of interest to the firefighter, and we looked at how they changed as they were walking through the world. We used force plates to look at how the forward to backward loads as we're crossing over an obstacle. If you push forward very hard or push back very hard, it's much more likely for your foot to slip. And see how that was affected by the different fatigue levels, as well as the weight of the SCBA itself. Because as you impact the ground, the more ground reaction force you have, that shock is sent up your body into your joints, increases a risk for musculoskeletal injuries as well. So we started off by having our firefighters just walk down a obstacle course. So what you see number 1 right here in the middle, they walk down there. In the middle, there's an obstacle that they cross over. It's an obstacle that's similar to the size we might find on the Fireground. So we look at, with the different size of the gear and the different levels of fatigue, can they cross over that obstacle without contacting it? What's the differences in clearance over that obstacle, which tells us a little bit about the risk. We then have them walk up and down this 3-step staircase, really similar to the stairs you might see going into and out of the front stoop of many people's homes, and tells us a lot of information about just stair crossing, how well we can move up and down those stairs. And both of these were done with the motion capture system. We then had them go down number 3 here. This is a carpet. This is a gait right walk system. It looked just like a carpet to the firefighters walking on it, but it had about 2,000 embedded pressure sensors, so we could get some very accurate information about each individual step that firefighters take as they're walking through the world. Then moved over to number 4 here. It was a false wall that we put together. There's 16-inch on center stud space. We wanted to look not just here at the biomechanics, but how well firefighters could pass through these stud space. If you had to make a breach in a wall and get from one cavity to the next, how would that be affected by the different size and geometry of the self-contained breathing apparatus? And then went to number 5. This is go back one. Number 5, which is a functional balance task that we put together in order to determine how well firefighters could move on the fireground without falling off, being able to turn within a specified area, bend over, stand up, sit down, and move within the gear the same types of movements you might have on the fireground, where we looked at the amount of time it took to complete the task as well as the number of errors that were made on there, so we could quantify the balance of the firefighter. And that's critical because if someone loses their balance, or if their balance is impaired, slips and trips don't always end up in falls, but if they have impaired balance, then it's more likely to end up in a fall. Okay? So I just want to very briefly go through a little bit of this data for those of you who are going to take a quick look at it in our report. Just a few of these different tasks that we had the firefighters go through. And here's a little bit of data from the obstacle crossing course. And again, this is firefighters walking down a platform and stepping over an obstacle similar to what they would have on the fireground. And what we found was the contact. Now, this obstacle was designed to fall away if it was contacted, so that it would not cause a trip. So when they went down the walkway and tried to step over this obstacle, after firefighting, 52 contacts were made with the obstacles compared to 31 before the firefighting event. And these are the exact same individuals. So we had a much higher rate of contacts, which, again, while that does not indicate a trip is going to happen, but it increases the risk of the trip because a firefighter was not able to cross, not able to fully clear that obstacle. We also found that there was a significantly larger number of contacts with the obstacle after 2 cylinders of air. So when we had them go through the 2 bouts of activity, they were more likely to contact the obstacle than after they completed that first bout of firefighting activity. So again, the risks increase after the firefighting activity and increase even more the more fatigued you become after that second bout of activity. We've got a lot of detailed analysis of that gait cycle so we can provide even more information to understand how this might occur. What are the mechanisms for these things that are occurring on the fireground? And you can see the data here on the bottom side, the bottom of the slide. Blue are the contacts before firefighting and red are the contacts after firefighting. You see in every case except for one where there are some interesting things happen in a 45-minute model, but every case except for that one scenario, we had more contacts in the red bar post than we did before. So the risks are increasing post-firefighting. Again, something important for us to understand for the incident commanders, for our safety officers. When they come out of the building, we're more likely to see some of these trip and fall incidents. And it appears that there's even larger risk after that second cylinder of air. Another little bit I want to show you is just the normal walking. So this is the firefighters walking down the gate mat. So they're walking on carpet without anything in their way. And we found that there was really no effect of the SCBA on this as well. And there was a minimal effect of the SCBA on the other studies. But what was a larger effect was the second round worth of firefighting activity. And again, without having the time to go into detail of what the plot shows in the top here, what we found is minimal differences. After the firefighters came out from the first bout of air, they walked very similar than they did before they went in. Their gait cycles were very similar to what they would just normally do on the fireground. But once we got to the data here towards the right-hand side, the 2R and the 2B, or the back-to-back, after they came out the second bout, much different. They were walking in a much different fashion. Okay, much slower walk, a lot more time in single leg stance, a much shorter stride. It was more difficult for them to walk down this pathway because of the additional fatigue of that second cylinder of air. Again, we see that there is an impact from firefighting activity, but that second round becomes much more important than I think we had ever imagined before. And I want to jump ahead to number 5, which is this functional balance task. And again, the data here is really interesting because if we look at the top, this is the amount of time that it takes to complete the task. And we've grouped these things, hopefully, which makes it a little easier for everyone to see. But yellow, this is a 30-minute SCBA. Red is the 45-minute SCBA, and the blue is the 60-minute SCBA. And what you see, the time it takes to complete this functional balance task, it increases. So this is when the firefighters, there's no fatigue. They're as rested as we can have them. It takes longer to complete this task as the SCBA gets larger. So this is one indication that we are having some effect on our ability to balance on the fireground from the size of the SCBA. What's also interesting here, if you look at the solid lines, this is before and after firefighting when just doing one round of activity. And what we found here that is interesting is there's really no difference in the time to complete. In fact, in most cases, we see a slight reduction in time. So they actually complete the task a little bit faster after they've gone through one round of activity. And we found that the case in some other studies where maybe reaction time is faster after a firefighting bout than it was before, whether it's because muscles are warmed up or whatever. We haven't found the specific reason for that. But after one round of activity, it seems like they're performing about the same but slightly worse. Now if you look at the dashed lines, which is the yellow dashed line, that's a 30-minute after they've completed 2 bouts, and the 60-minute after they've completed 2 bouts, they're going the other way. What this is showing us is the time to complete after that second bout of activity is actually increasing. So they're much slower after that second bout of activity, even though they make about the same number of errors after the second bout of firefighting activities. Again, we're starting to understand here for the first time what this data can tell us, and hopefully we can improve the awareness out there in the fire service. Working more than 30 minutes on the fireground really puts us at some increased risk for some of these slip, trip, and fall injuries, as well as the overexertion and strain. We know that there's an impact of working on the fireground, but that impact becomes much larger when we are working twice as long. Again, that might be an operational reality for some of us, but it's something that we need to consider that our firefighters are being affected for. Okay, so I'm going to bring this to a close here, and I just want to introduce this data summary. This is something that's in the report that I will show you how to get to that report at the end of the slide here. But this is a visual comparison of what the data shows for you. Everything in red. So we've on the left-hand side, these are some of the measurements that we took from heart rate and core temperature during the work, activity counts, the ability to do the job, some of the obstacle crossing errors, some of the gait and balance behaviors you can see here. When we look at along the top here, so in each column we have what is it we're comparing. So a pre versus post firefighting activity. Did the heart rate go up or down? And it went up, and that in some cases is something we need to worry about the risks for increases in heart rate or core temperature. Or if the perceptions goes down, they perceive themselves to feel worse. We need to look at. So red is a negative, a potentially negative change, whereas green is a potentially positive change. So if we look through the pre versus post firefighting, we had a lot of red arrows on here. We did see an improvement in the obstacle crossing clearance here in the middle and improvement in the functional balance time. They're small, which is why they're small arrows. But this is a summary of the data we can have there. If we look at the size of the SCBA, the 30 versus 45 and 60, you can see for most cases we had relatively minimal impacts. The largest impact we had here was the time to get through the functional balance test. Right. But then if you look at the far column all the way to the right, This is where we see the largest impact for almost all of these measurements that we took. So the key message here is these are the critical aspects. We see negative changes and larger changes when we get to the longer times of working on the fire ground. So the good news in many cases is if you make that decision, go from a 30 to a 45 to 60-minute air bottle, the design and from the study that we've run here, that's not as nearly as large of an effect as it is from going from a one-cylinder of air work to a two-cylinder of air work. Okay. So this is included in our final report, and a lot of information that backs this up can be found. And of course, the report is free to download from our website, which I'll conclude with. But here's the conclusions and recommendations from the project. First of all, one of, I think, our most important issues we want to make sure that's out there is the awareness of how PPE can impact safety of movement. We need to understand this. We need to understand that firefighters interact with their gear. And it's not just something that we wear on top of us. But because the SCBA has such a large effect on the range of motion, changing our center of mass, and it makes it a little more difficult to recover the balance, we need to take that into account for our firefighters. Because we understand that the slip, trip, and fall injuries are often the result of not being able to maintain balance on slippery surfaces or contacting the obstacles on a cluttered, what's commonly a cluttered fire ground. So the size of the SCBA had some small effect on those, and that's important to consider. Right? At the same time, if the fire department does transition to these larger SCBA for the other reasons, the other very good reasons that we might have to use larger SCBA, it's our recommendation that it be done by looking at everything that's in there. We understand that the additional air can provide an important reserve safety and the ability to work extended durations for the firefighters. But that extended work duration, really, there are some firefighters who are fit enough to handle that and do that safely, while other firefighters, the 30-minute SCBA in many ways forced a work rest cycle, forced them to come out. Okay. The longer duration SCBA might allow some of those fit firefighters to work longer and continue to work as long as they possibly can. But the additional weight and the bulk has some important impacts in how we move, and the extended work time is going to make those decrements even more difficult. So if the extended duration SCBAs are to be utilized, it's our recommendation that we maintain the work rest cycles typical of a 30-minute SCBA. And had a very nice conversation with Mike Galliano from Seattle the other day. Really talk about how they've been able to use that additional air. They expect their individuals to come out of the fire before they go on to the bell, and that additional air that's in the SCBA can be used as a safety, so an increased level of safety. So we've found it doesn't really matter from this study if you're wearing the 30 or the 45 or the 60-minute air bottle. If you come out at that same time period as you normally would with a 30-minute SCBA, and you assume the rest of that is just reserve, we had very similar results regardless. This, again, might require manpower, might require mutual aid to minimize the amount of need for the second cylinder. But it's important to remember that there are a significant increase in core temperature, heart rate, and a decline in our safety of movement after we've used that second cylinder of air. So if we keep the firefighters in on that, until that 60-minute SCBA, if we use that end of service time indicator as the time to come out, that dinner bell, it's time to get out of the building, now we have firefighters who are potentially at higher risk for some of these other injuries we talked between there. The short break between the work was a small but important effect for our firefighters, but it's critical that we provide rehab to the firefighters as quickly as possible, and even something that we might not consider a formal rehab program, such as you come out for a swap of air, change an air bottle, get a bottle of water as well at the same time. And that will help you to possibly help some of our firefighters to reduce some of these risks. So again, this was just a quick teaser for the report that we have on our website. You can go to www.fsi.illinois.edu/research and download this report and many of the other reports that we've done from the different studies at IFSI. They're all in PDF form. They're free to anyone. And I am happy to answer any questions about this. My email you can easily get to my email through the website itself. You can also follow us on Twitter at IFSI Research, where we put out all the new information from each of our studies, such as the study that we have right here. So that's the information that I had.
And they can come to FDIC and pick your brain for hours and hours and hours.
Absolutely. Yeah, FDIC, we presented this, and we'll be there quite a bit this year, won't we, Bobby?
You will be there quite a bit, my friend. Yes, you will. So, Gavin, there are a couple of great questions I want to go through, and Ed's been waiting. He wanted to know, how was VE measured while firefighters were wearing SCBAs? Ed, and I believe that's Syncule, S-I-N-K-U-L-E, Syncule.
Yeah, that's a great question. So what we did for this, there is, in the laboratory, there are metabolic measurements. So anyone who has done a maximum exercise treadmill test has had to go through use either a metabolic cart, or now there's a portable system that's being used. The system we use is made by a company called Cosmed. There's other companies that are out there, but what it is basically all of the air that is exhaled is funneled through a mask into a portable analyzer that measures the rate of air as well as the amount of oxygen and carbon dioxide in that. And again, we could talk about this for quite a bit of time. Typically, that requires someone to wear a mask, a specific mask that comes with these systems, or bite down on this tube, which you'll commonly see. Maybe from a Gatorade commercial or something like that, where you can see people doing these maximum tests. It's collecting all their expired air. For this study, we had a brilliant young student who figured out how to interface that portable system with an SCBA face piece. So we basically took the exhalation port, gathered all of that air, and pushed it out into this laboratory-grade instrument that the firefighters were wearing. They basically wore it on the front of their chest. So it weighed about a pound that they wore on their chest. So as they were moving through the world, through the activities, we were able to measure the expired air in a very, very accurate manner. That's not something that we could do in a burn building because that instrument is just too sensitive. And that's one of the reasons we wanted to do it in the environmental chamber. But it's a laboratory-grade instrument that allowed us to measure that in real time.
Wow, and Ed, thank you for a great question. What a great answer. I've got a wonderful question here from Chad Sauls, and Chad asks, in program design in relation to VO2 max, heart rate, etc., what work-rest ratio intervals should we program? 2-to-1, 3-to-1, and what target of heart rate? Very in-depth question.
Well, it's a very in-depth question, and one that I think I'm going to have to say we don't know. From a work-rest cycle and from a target heart rate, it depends. Let me go to the heart rate question first. There's a lot of people who heart rate is very easy to measure. We have it available to us in our exercise and even on the fireground. There are some instruments that are available out there that can measure heart rate on the fireground, but it's also a very difficult measurement to make many decisions off of. There are some individuals who can be working at 75% of their max or 80% of their max heart rate for a significant period of time. Some people who are fit, they don't have any underlying cardiovascular disease, and it's not dangerous for them to be working at high heart rates for significant periods of time. Whereas there's other individuals who we'd be a little bit more concerned about. So that question really it depends on the individuals themselves. We would like to have a red, yellow, green to say if you're in this range, you've got to come out. If you're in that range, you're safe to go back in. And this is a place where Denise Smith, who's been a longtime collaborator and a great friend of ours, has done a lot of work on physiological status monitoring. And we're not there yet to determine where someone should be in what range or not. And I'd say the same thing for work-rest cycles. Most firefighters we found are very good at policing themselves, at least in the fireground. As I mentioned earlier, the breathing rates and the heart rates we'll often find lower for the less fit firefighters. And initially, and Denise talks about this in a lot of her presentations, initially we were kind of shocked by that. Had to go back and check the data. But what was happening, the firefighters who weren't as fit just weren't doing the same amount of work in many cases as those who were. And those who were could work at a much higher rate for a much longer period of time. And I think a lot of the work-rest cycles, at least within the firefighting activity, within one cylinder of air, a lot of those work-rest cycles depend on the coordination between the activities in the fireground. It's really hard for us to be able to determine one versus the other. If you talk about rehab or bulk work rest cycles, the NFPA recommendation is you go to rehab after 2 cylinders of the 2 30-minute SCBA or 1 60-minute SCBA. But again, the way we teach rehab is you need to really look at the individual. There are some individuals after 1 cylinder of air, they need to report to rehab. It's not safe for them to continue, or we just need to keep a little bit closer eye on some of those. Whereas other individuals, they've gone through 2 cylinders of air, they're in rehab for 5 minutes and they're ready to go back in because that's just where they're physically at on the job. So when we talk about rehab or talk about work rest cycles, the hard part is you really got to know your people, know their capabilities, and have trust with them that they're not going to try to sneak back in as much as that's possible. So I hate to give an answer that says it depends, but like many other things in the fireground, it depends. And you need to use the information that's out there to make good decisions for your firefighters and firefighters for themselves.
Well, I think this
again another great question.
Kind of that was a great question, Chad. We got this from Stan Burling, and I think this kind of wraps it all up. And I think, again, I think the good doctor here is going to tell us it kind of depends, but I think that Stan is on the right track. He says our SOGs direct firefighters to exit the IDLH when 1/2 of our 60-minute cylinders are consumed. This presentation looks to validate that, if I'm understanding correctly. I think it leans in that direction.
Okay, sorry, could you repeat the question? I got a knock on the door.
He said their SOPs direct them to leave at 1/2 of their consumption on their 60-minute cylinders. He said he thinks that the presentation kind of validates that SOP if he's understanding the data correctly, and I think he is.
Yes, my recommendation would be to continue to work as you would, assuming that you've got a 30-minute SCBA on your back. There's nothing that suggests that that's optimal, but we're finding that there is a significant difference after the second round of firefighting activities if you continue to work that same amount. We find that after that first cylinder, so roughly halfway through your 60-minute SCBA, there are impacts on the body, but they're not nearly as significant as we go beyond that. So we haven't parsed it out on a minute-by-minute basis, but what your SOP says is really what kind of our last conclusion recommendation slide is, that, yeah, consider that you're working as you normally would with a 30-minute BA, and then the rest of that is a safety. It's a reserve. I very much appreciate that SOP, and again, something that in conversation with Mike Galliano out at Seattle, something that he talked about, that they've gone to a 45-minute SCBA, but he's very much in favor of that same type of thing, where it's expected that you're out of that building before you go on the bell, before you're on that end of service time indicator. And then if you do that, then everything else you have is reserved. The challenging thing is having the firefighters disciplined, the self-discipline to do that, because a lot of us, the bell is kind of the indicator it's time for me to get out of here. Unless you have a good enough clock in your head or a good enough incident commander or incident command aide who can say, okay, they've been in there for this time, it's time for them to get out. A lot of us, that visual cue is really what it is. If we get too far into the tunnel vision or too focused on the job at hand, I love that SOP, and I'd love to hear how it works for them on the fireground and how they're able to train their firefighters to follow it, because I very much agree with that plan.
Well, Doc, on behalf of everybody here at Fire Engineering and the Penwell Fire Group, I can't thank you enough for an amazing job. Also, our sponsor, Avon Protection, for allowing us to put on today's presentation, Clearing the Air, What Do You Get for 30 Minutes? Everybody, this presentation is going to be up on our website within 24 hours. You can access it at fireengineering.com. We will send you a reminder message if you've registered. It'll be sent directly to the email you provided us with a direct link to the archive. We can't thank Avon Fire enough. Please go to Avon-Protection for their website. Please go and look at the incredible products that Avon supplies. That's avon-protection.com, avon-protection.com, and look at the amazing thermal imagers, air packs, and everything else that Avon has to offer. And thank you so much for allowing us to put on this presentation today. Doc, thank you so much for being with us. Look forward to seeing you at FDIC. To everyone who was with us today, thank you so much, and please remember to be careful out there.
Absolutely. Thank you, sir.